Yes, my name is Derek and I'm presenting question 2 of the coursework. The question was that we find the two fastest runners with the time they finished. And here is the code that I came up with. I mentioned a class and named it marathon. Then this is the main class where I listed arrays of the names and the arrays of the numbers. The arrays of the names are strings and I named them names. So it is names equals the numbers, the names of the strings. Then the integer, the array of the numbers is also listed as times. So it is integer int, then the symbol for the array, and then I named it times. So this is it. From there I started declaring. I declared int, the fastest index, to be equal to find fastest runner, then into times. Then the system will print for us fastest runner, then semicolon, then space. It concatenates it with the names of the fastest index, names in the fastest index, then concatenates it with a time of, then space, then concatenates it with time of the fastest index in the times array. Then it also concatenates it with the minutes as we have been given in the question. So this for the second fastest runner, we do the same. We declare that the integer int second fastest index is going to be find the second fastest runner into brackets times comma then fastest index. So this one as well will print for us just like the first one, the second fastest runner, then space, concatenates it with names of the second fastest index, plus, or concatenates it with times of the times in the second fastest index of the second fastest index. So here we are going to put two methods. The first method is for the fastest runner. The second method is for the second fastest runner, meaning it's going to select a runner in the array but exclude the most minimum of the times. So here on the first method, first this is the fastest runner, you declare the fastest index to be equal to 0 for int I is equal to 1. Then you terminate. I is less than times dot length, then you terminate, then you increment I. So you open the bracket. If open brackets times of the I is less than times of the fastest index, then fastest index is equal to I. Then we close up the brackets and this function will return the fastest index. So for the second method, it's going to be a declaration of the second fastest index to be equal to fastest index equaling to 0. Then this is an exception for the most minimum. So we are going to say equals 0 question mark 1 semicolon, then 0. We terminate. That is it, to exclude the most minimum, and the most minimum is our is our fastest runner. So we come and say for I is equal to 0, terminate. I is less than times the length, and then I increment. If I is not equal to the fastest index and times of I is less than times of the second fastest index, then the second fastest index is equal to I. We close the curly brackets and return the second fastest index. So I hope this is my program, and this is what I thought is the solution to the coursework question number 2.